I want to work through this question for you. It's called question 1. It's from this book. I've also put a copy with this video with the question as well. I'll read it out to you. A Coast Guard station monitors the movement of ships in a channel. At noon, the station's radar records 2 ships moving at constant speed. Ship A is at the point, position vector -3i plus 10j kilometers relative to the origin, and has velocity 2i plus 2j kilometers per hour. Ship B is at the point in position vector 6i plus j kilometers and has velocity -i plus 5j kilometers per hour. Show that if the 2 ships maintain these velocities, they will collide. Okay. I like these questions, ships colliding questions, okay, because they're fascinating to me. All right. So what we're going to do is we're going to work out what the position vector of each ship is. Okay. So let's start with ship A. Okay. So ship A, I'm going to call that the position vector of A, so R of A. All right. So at the beginning, it is at the point with position vector -3i plus 10j. All right. So -3i plus 10j, and then it's got velocity 2i plus 2j. Okay. So that's going to be plus 2i plus 2j t. Okay. Do remember that to find the position vector at a particular point, you've got to work out, well, first of all, write down what the initial position vector is, and then add to that the velocity multiplied by the time. Okay. So that's for ship A. Now, recall it's often better to write it in terms of i's and j's separately, so I'm going to do that. So we've got -3 plus 2t, that's the I component, and then we've got 10 plus 2t, and that's the j component. All right, that's for ship A. We do the same again for ship B. All right, so ship B, it starts with position vector 6i plus j, so that's 6i plus j, and then it's got velocity -i, so let's put it in, so plus -i plus 5j, and that's multiplied by t. Okay. And as before, it's better to put this in terms of i's and j's separately. All right, so we've got 6 minus t, I, and plus 1 plus 5t, j. Sure, they collide. Okay. Well, when they collide, they occupy the same point on the map. What that means is the x coordinates and y coordinates are identical, or in this case, the I components are identical and the j components are identical. So that's what we've got to do. Okay, we've got to show that when that equals that, you get the same value of t as when that equals that. Okay, or there's an alternative which I'll show you in a minute, but let's just do that first of all, equating the I components. So we've got -3 plus 2t is equal to 6 minus t. Let's solve that. So we're going to have 3t equals 9, t equals 3. And then also the j components, let's do that here, shall we? We're going to have 10 plus 2t is equal to 1 plus 5t. So solving that, we've got 3t equals 9, exactly the same as this. T equals 3. And because we've got the same value of t, that means there's a collision. So I'm just going to write down there for collision. Okay. Alternatively, what you could do is this. Okay. Once you've worked out a value of t, substitute in and work out what the position vectors are. So when t equals 3, where is ship A? So it's -3 plus 6, so that's 3i. And then 10 plus 6 plus 16j. Okay, and then do the same with B. Okay, so position vector of B is going to be 6 minus 3, which is 3i. And here it's going to be 1 plus 15, which is 16j. Okay, and then show those 2 position vectors are the same. Okay, hopefully that was making sense to you. So let's move on. The Coast Guard radios ship A. Well, they better do really, haven't they? Otherwise they're going to collide. Okay, and it orders it to reduce its speed to move with velocity. So that's one thing they can do. They don't have to, you know, tell it to stop. Okay, take drastic action. They just sort of tell it to reduce its speed, or in this case, it's telling us to move with a different vector. Remember, a vector is like a direction of motion, but the vector direction is not changed. So the I plus j, basically instead of 2i plus 2j, they're telling it to half its speed. That's what they're doing. You don't need to know that really, but I'm just adding a bit more there. Okay. So it says A's got to now move with velocity I plus j. We've got to assume from that, what that means is this will be the same, except that is now different. Okay, so look, what I'm going to do is to just put that down now, okay, before I forget. So the new position vector of A is going to be negative 3 I plus 10j, okay, and then plus I plus j t. Let's just make sure I've read that correctly. Negative 3 plus 10j, yeah, and I plus j. And so what that means is the new position vector of A is negative 3 plus t, I plus 10 plus t, j. Right, so that's the new position vector of A. Okay. It says, given that A obeys this order, good job really, isn't it? Good job. Okay. And maintains this new constant velocity. It says, find an expression for the vector AB. Now, if you've looked at the answer in the back of the book here, the answer it gives you is this. So that probably means there's a misprint in the question. It probably means that part B, they wanted you to find what the new position vector of A was. Okay. But since the question was printed as find an expression for the vector AB, let's just do that. Okay, let's just do that. All right. So the position vector of AB. I'm going to write it up on this board here, if you don't mind. Okay. So recall that to find AB, what you could do is you could do the position vector of B subtract the position vector of A. Okay. Why does that work? Well, let me just briefly show you. Okay. So suppose this is where A is, this is where B is. Okay. What we want to find is what AB is. That's how you represent AB as a vector. Okay. From the origin there, that's where A is. Okay. And that's given by the position vector of A, which is now that. Okay. And from the origin, B is there, which is the position vector of B, which is given as that. Okay. So to work out from A to B, you've got to go negative RA plus RB, which is RB subtract RA. Okay, hope that made sense to you. So when I just flip this back over, that's why I've written it out like that, RB minus RA. Alright, so doing that then, RB is that and RA is that. Okay, so what I'm going to do, maybe if I just hold it up here so you can see what I'm doing. Okay, so I'm going to have 6 subtract negative 3, so that's 9, and then negative t subtract t, so let's subtract 2t. So it's the I component, okay? And then 1 subtract 10, so that's going to be negative 9. And then 5t subtract t, so it's plus 4t j, okay? And if I put it in terms of, oh, it is in terms of i's and j's already, yeah. Well, that's it, because that's what AB is, right? So 9 minus 2t I plus negative 9 plus 4t j. So for those who actually worked out what AB was, that's what you ought to have got. Okay. Let's move on to part C. Find to 3 significant figures the distance between A and B at 1500 hours. That means when t equals 3. All right. Now look, we've already got where B is when t equals 3. Yeah. So I don't know, some of you might have used that. Okay, I'm not gonna. Okay, what I'm going to do is I'm going to use that fact that I wrote down earlier, and I'm going to work out where A is at 3 hours. Okay, so A will be at negative 3 plus 2, well, 0y, isn't it? And then 10 plus 3 is 13j. Okay, so what we need to do is work out the distance between them when that's where B is and that's where A is. Yeah, you agree with that? Good, I'm so glad you said yes. Okay. Can I just rub some stuff off? Because I don't need all of this anymore, do I really? Let's just check I don't need that. So I'm just, don't worry, I just dropped my pen lid. It's fine. I'm just going to get rid of this. Okay. Maybe I'll just write it down again. Okay. In case I need it. So position vector of A is -3 plus t I plus 10 plus t j, okay, and RB, let's just move that up a little bit, okay, 6 minus ti plus 1 plus 5t j, so that's that, okay. Yeah, so I need to work out the distance between them here and here, okay. So the distance is going to be the difference in I components, which is 3, and then difference in j components, which is 3. So it's going to be 3 squared plus 3 squared, okay, square rooted. Remember to find the distance between any 2 points, so there, okay. So you find the I component, j component, square it, square that, add them together, square root. So it's Pythagoras' theorem to work out the magnitude, okay. And so that gives us root 18, which is 3 root 2. It said to a certain number of significant figures, didn't it? So maybe I need my calculator to do that. So what is that to 3 significant figures? 4.24. Okay, 4.24, and that will be kilometres. Okay, that's that bit. And find the time at which B will be due north of A. Okay, find the time at which B will be due north of A. Okay. Well, I don't need this anymore, so I'm going to get rid of that. Now to do this, I'm going to have to use that up there, which is why I've written down again. Okay. Well, when one is due north of the other, what can you say? Okay. I'm sure you can say lots, but what's going to be the most useful here? Okay. So when one is due north of the other, one's there and one's there, isn't it? Okay. You can connect them by a vertical line. Okay. What that means is we might not know anything about the vertical displacement, but we do know horizontally there's no difference. Okay. They're 0 kilometres apart horizontally. So that means the I component is 0. All right. So sorry, not 0, equal. I wish I hadn't said that. Never mind, it's only a small bit. The I components are going to be equal. Okay. So what we're going to do is we're going to set that equal to that. Okay. So we have -3 plus t is equal to 6 minus t. All right. And we're just going to solve that. So we have 2t equals 9 and t equals 4.5. It says find the time, and it began, let's just check, began at 12 noon. Okay, so that means it must be 4:30 in the afternoon. Okay, so to write that using 24-hour clock notation, you write it as 16:30. Okay, or if you want, you write it as 4:30 p.m. The PM has to be there if you're using 4. Okay, so 16:30 or 4:30 p.m. And that's it. That's the question. Hopefully you found that enjoyable. Hopefully that was useful to you.